Hello guys, in this video I'm going to show you how to solve triplet sum close to target. So given an array of unsorted numbers and a target number, find a triplet in the array whose sum is close to the target number as possible. Return the sum of the triplet, right? If there are more than one such triplet, return the sum of the triplet with the smallest sum. Okay, so given this input, right, -3, -1, 1, 2, target is 1, so we should return the sum of the triplet that is closer to 1, right? So that triplet should be -3, 1, 2, which sum up to let's say 0, right? So with the closest sum to 1, which have the difference of 1, right? Well, this one is pretty similar with the one we've solved previously, which is triplet sum to 0, right? Our previous problem. We also need to find a triplet, right? But in that program, we have to find a triplet that sum up to 0. Here we need to find a triplet that closest to a target, right? So the approach is the same, right? But here we need to keep track of the current um, the best answer, the current best answer, right? So the the triplet that sum up to the triplet that sum up the triplets that its sum closest to the target currently, right? So if we iterate through the array, and if we find a better answer, we're gonna update that triplet. Okay, uh, let's run to this one manually. For this, we're given an unsorted array, so first we need to sort it, right? We need to sort it. So after sort it will be same, yeah, right? So because we have to find the sum of three number, so we're gonna use 3 pointers, right? I'm gonna use 3 pointer. Let's say we're gonna fix the first pointer here, right? Okay, we're gonna consider one pointer to be fixed, right? So the first number is always -3, right? And the two other numbers will ranges from -1 to 2, right? Okay, we use two other pointers, right? So I wanna keep track of the current sum. Let's say, and also the current diff, right? Here is the sum, but we need the difference between the sum and the target, right? To see whether the current sum is close to our target. The current sum now is, let's say, here is minus 3 plus minus 1 is minus 4 plus 2 is minus 2. So the difference with 1 is 3, right? Okay, so the best answer currently is 3, right? Because it is the first triplet that we consider. So how do we move on? Uh, because uh, we can find a way to move on based on our current, based on the fact that the current sum can be is smaller than our target, right? And and the second fact is that our array is sorted, right? So because our current sum is smaller than the target, we probably want to add up um, to increase the sum in general. So in order to increase the sum, right, I'm gonna, because this pointer is fixed, I'm gonna change these two pointers. I have the choice to either move this pointer rightward or this pointer leftward. Because we need a bigger number, I want to move this pointer rightward. So, okay. So now our current sum will be updated, right? So 3 plus minus 3 is 0. The difference is 1, right? And the best answer, because the current diff is smaller than the the best answer currently, so I will update it. The best answer now is 1, right? Okay, so here you can do the same logics, right? uh, as the previous step, which is compare the current sum 0 with the target is still smaller. We need bigger number, so I'm going to move the this pointer rightward to have a bigger sum. But as I move the pointer rightward, it's gonna meet the this pointer. So it is when we're done. We'll stop here, right? Because we need three numbers at least to form a sum, but here we can't form a three numbers sum of three numbers, so we're done with uh, sums that start with minus 3. So next choice is, because we fixed the first number to minus 3, so now we're gonna fix the next number minus 1, right? And so on and so forth. You know the idea. I want to move on from here. I'm not going to go into details about this. So let's jump into coding. Okay, we need to sort array first. Array sort. We take in two arguments A and B. Want to sort the array in ascending order, so the callback functions return A minus B. Okay, we need to fix we need to fix one number, right? So let's say the first one is first index, right? On from 0 to array the length as long as still less than this one, first index plus. Okay, but the questions here is do we need to run all the way to the end of the array? The answer is no. We need at least two other numbers, right? Except for this one. So I'm not gonna iterate until the end of the array, but uh, I'm gonna have at least two other numbers, right, at the end, right, so that uh, we can form sum of three numbers. So here is I'm gonna run as long as still less than array length minus 2 so that we can have two other numbers, right? Okay, so now we need two other numbers from here. Let's say we need two pointers, one from the start and one from the end, right? So second index, if from what from start is actually from first index plus one, right? And third index is array length minus one, which is the last number. Okay, so as long as let me use a while loop here. I'm not sure how many loop do I have here, so I'm going to use a while loop. So as long as the second index is still less than the third index, make sure that we have at least three numbers, right? So the current sum is array at first index plus array at second index plus array at third index. Okay, so the current diff is map absolute of current sum minus target. So to make sure that current sum minus target or target minus current sum is the same, it's always going to return a positive number, right? When I need the best answer here, the best, let's say it's the best difference. Best difference is initially is a very big number, infinite. So to make sure that for the first iteration, it's always gonna be less than this diff. Infinite and also the current sum as well. The best sum, let's say the best sum. Infinite. Why is that? Why do we need the best sum here? Because here we have a requirement there are more than one such triplet, return the sum of triplet with smallest sum, right? So if I have two numbers with the same difference, uh, two sum with which share the same difference to the target with the target, I'm gonna take the one with the smaller sum, right? Okay, so uh, here I'm gonna check. So here there are three cases here, which is if current sum equal to no, I'm gonna update the best the best difference first, right? Mm, so if the current difference is less than the best difference, which is always the case for the first iterations, current difference is less than the best difference, and and the what's that? Or instead, I think it should be or. So if this is true, it's not gonna consider uh, the next expressions. But if this is false, wanna consider the next expressions. If the current difference is less than the best difference, or the best sum. By the way, I think it should be n instead. We need both of these two current difference is less than the best difference because we need a sum that is closer to the target, right? So if this is true, current difference is less than difference, and best sum is the current sum. No, because no, if this is the case, I'm not gonna consider this one. I only consider this scenario when current difference is equal to best difference, right? So if the current difference is less than best difference, I'm gonna update best difference to current difference. And what else? And best sum to the best sum to the current sum. Okay, and at the end I'm gonna return what? I'm gonna return the sum of triplets, so I'm return the best sum. Okay. So here, if this is not the case, it can be the case that else if current difference is uh, current is equal to best difference, right? And the current sum is less than, which is the case if there's more than your sum, so right? Return the sum of triplet with smallest sum. It's the same difference, but when I take the smaller sum, right? Current sum is less than the best sum, then we do the same here. Okay, so the logic is the same. So let's abstract it out with it. Uh, let's do it later. Uh, so after this logics updating the answer, we'll now move on to find the better answer, right? So there are three cases here, which is if uh, if the current sum is if the current sum is equal to the target. In this case, I will return 0 because we can't find a difference that is better than 0. Now, I want to return the current sum instead. Okay? I want to return the current sum instead. Else, current sum is less than the target. It means we need a larger number, so I'm gonna move the second index, increase the second index, move the pointer forward, else if, and L, the last case, I need a smaller number, so increment by 1, third index by decrement is by 1. Okay, that should be good. Just 2 and 5. Oops. Receipt 2. What's wrong here? I double check it. First index, okay. Second index is first index plus 1. Third index is the last one. The best difference, the best sum. Okay. So as long as to make sure that we have three numbers, current sum is sum of these three. Okay, the condiff is consum minus the target. Okay, the difference from consum to target. So if the condiff is smaller than the best diff currently, I'm gonna update the one we want the smaller difference. The best diff is gonna be condiff. The best sum is gonna be the consum. If this is not the case, you consider consum best. If condiff is equal to best diff, I'm gonna check the sum. If it's smaller, update it. Same here. So if the consum, I'm gonna return the consum. Okay, so if consum we need a smaller number. Uh, Sum of the triplets, best sum. Not sure what went wrong here. I'm gonna debug it. The consum two, which is these three guys. 0, 1, 1 here. Is smaller than target. Okay. It's not gonna run into these guys. So now second index equal to third index. So it's gonna break. What's the next one? Whoops. What went wrong? Oh, my bad. The best sum should be returned after this one. I'm gonna move these two guys outside. I think it will fix. Okay, it works. So that's it for this video. Thanks for watching. See you in the next one.